The penultimate assumption is the no autocorrelation assumption. It is also known as no serial correlation. This is my least favorite as it cannot be relaxed. Mathematically, it looks like this. Errors are assumed to be uncorrelated. Where can we observe serial correlation between errors? It is highly unlikely to find it in data taken at one moment of time, known as cross-sectional data. However, it is very common in time series data. Think about stock prices. Every day, you have a new quote for the same stock. These new numbers you see have the same underlying asset. Without getting too much into the finance, ideally, you want them to be random or predicted by macro factors, such as GDP, tax rate, political events, and so on. Unfortunately, it is common in underdeveloped markets to see patterns in the stock prices. There is a well-known phenomenon called the day of the week effect. It consists in disproportionately high returns on Fridays and low returns on Mondays. There is no consensus on the true nature of the day of the week effect. One possible explanation, proposed by Nobel Prize winner Merton Miller, is that investors don't have time to read all the news immediately. So, they do it over the weekend. The first day to respond to negative information is on Mondays. Then, during the week, their advisors give them new positive information, and they start buying on Thursdays and Fridays. Another famous explanation is given by the distinguished financier Kenneth French, who suggested firms delay bad news for the weekends so markets react on Mondays. Whatever the reason, there is correlation of the errors when building regressions about stock prices. The first observation, the 6th, the 11th, and every 5th onwards would be Mondays. The 5th, 10th, and so on would be Fridays. Errors on Mondays would be biased downwards, and errors for Fridays would be biased upwards. The mathematics of the linear regression does not consider this. It assumes errors should be randomly spread around the regression line. So, how does one detect autocorrelation? A common way is to plot all the residuals on a graph and look for patterns. If you can't find any, you're safe. Another is the Durbin-Watson test, which you have in the summary for the table provided by stats models. Generally, its values fall between 0 and 4. 2 indicates no autocorrelation, while values below 1 and above 3 are a cause for alarm. But what's the remedy, you may ask? The remedy is, there is no remedy. I told you in the beginning of this lecture, you cannot relax this assumption. The only thing you can do is avoid using a linear regression in such a setting. There are other types of regressions that deal with time series data. It is possible to use an autoregressive model, a moving average model, or even an autoregressive moving average model. And I'm not done yet. There's also an autoregressive integrated moving average model. Make your choice as you will, but don't use the linear regression model when error terms are autocorrelated. Our next lesson will be a lot more encouraging, I promise. See you there!